All right, guys, we're going to work on 12.2 today, which is subdividing a segment in a given ratio. You will see that in the video or the lesson in just a minute. That's going to be on page 106 and 107. So whatever the video says, that page is not accurate because it was last year's video, but it's the same lesson. Okay, so I'm going to go ahead and turn to 106, show you where you're getting the pages from the book, and then you're going to get started on that lesson. All right, so it is from the book. 106 is where you're going to put it. Here's the title for 106. First, you're going to get this from 604. I'll show you the 641. I can't even read. This whole thing from 641. Okay. Then, when you're done writing all that, you'll have two pieces, or technically three. Both of these are from 643. Okay. And this is from 644. So that's what you're going to cut out. Cut that out. And then the actual notes and explanation are in the video that follows. After you finish that, you have a book page to do, so you need to work on that.
Alright, we are going to be talking about dividing a segment. It's called partitioning, but we're going to call it subdividing. It's the same thing. It means breaking it into certain pieces. This is actually a really, this kind of question happens on the ACT like all the time. There's a formula for it in case you want to know, and I'll teach it to you, but I would rather use a graph, but I'll show you both ways. I didn't know about the formula until a couple years ago. Somebody was talking about subdividing a segment, and they were like, oh yeah, when you use the formula, and I was like, whoa, there's a formula? There is one. Not that you're excited about that like I was. Alright, so it says it takes just one number to specify an exact location on a number line. For this reason, a number line is sometimes called a one-dimensional coordinate system. That's important in a minute when we're doing X and Y. Obviously, it's two-dimensional. That's the difference. Okay, so the mile markers on a straight stretch of highway turn that part of the highway into a one-dimensional coordinate system. So this is just a number line coordinate plane is what it's going with. Alright, on a straight highway, the exit for Arthur Avenue is at mile 14. So A actually says we're going to mark that. So we're going to mark mile 14 with an A. 11, 12, 13, 14. So there's A. And the exit for Collingwood Road is at mile marker 44. 41, 42, 43, 44. And that's C. The State Highway Administration plans to put an exit for Briar Street at a point that is 2/3 the distance from Arthur Avenue to Collingwood Road. Follow these steps to find that. So, what is the distance from Arthur Avenue to Collingwood Road? 30 miles. How'd you find that? You also could have counted on the number line, but that would be a little bit more work. Okay. How far will the Briar Street exit be from the Arthur Avenue? How many? 20 miles? How'd you figure that out? Okay. 2/3 of the distance is 20 miles. So it'd be 20 miles away. Okay. Then what's the mile marker then? Okay. E says plot it. 31, 2, 3, 4. How did you know it was 34? Yes, that is going to be very important today. That is actually what the formula is, which is a miracle. I don't know how I never knew what it was. It's the amount it is away. It's 2/3 the distance times whatever the distance is plus the original number. That's what the formula is. I like doing it on a graph better, and I'm going to show you both. I want you to cut from the word explore all the way down to letter D. So we can put this in our notebook. And it will go in your notebook on page 102. So we're going to subdivide a segment when it's actually on a coordinate plane. So I said there was a formula for that, and there is one. And I will explain every piece, so when you see it and you're a little confused, it's alright. I did kind of explain this a second ago. I said you take, so x1 is the starting of the formula, plus k, and I'll tell you what k stands for in a minute, times x2 minus x1. That's the x value, comma, we're not there yet, comma, y1 plus k times y2 minus y1, close parenthesis. It's what I said a second ago, though. You take the biggest one and subtract the smaller one. So a second ago we did, was it 44 minus 14? We then multiplied it by the fraction, which is what k is, and then we added it to the beginning value. That's what this formula is saying. K is A over A plus B, which it's the ratio from like letter B 1 to 2. A is 1, B is 2, and we're going to talk about it. We're going to do B with the formula and on the graph. You get to decide which one you like better and use that. So, once you get that written down, we're going to look at letter B. So it's the same process of what we did before, but we have to do it for the x value and then for the y value. There is a more complicated way, like you could do the distance formula and find out what 1/2 of the distance formula and all this stuff. Takes a long time. You could do it, but I don't see any point in it. Okay, so letter B. If we're plugging this in the formula, we have x1, y1, x2, y2, and A and B. The reason that we actually have to make this k and it's not just 1 over 2 is because it's saying it needs to be a 1 to 2 ratio, which if you have a 1 to 2 ratio, how many pieces are there actually? 3, which is where this 1 plus 2 on the bottom of a third comes from. That's where the 3 is coming from. So the first thing we're going to do is find k. That's what you need to do every time. And k is 1 over 1 plus 2, which is 1/3. That's what we're going to use in a minute. Then I'm going to plug it in with this value here. So instead of x1, I'm going to use what value? -4 plus k is 1/3. And in parentheses, x2 is 2 minus -4, so what I put instead. This will be the x value. And if it confuses you to have all that in one set of parentheses there, we can go ahead and plug that in. I'm going to change colors just so we see this separation there. That comma separates. Here's x, we're going to do y. Okay. Then I have y1, 4, plus k is 1/3, times y2, and instead of, nope, it's positive, minus y1. So I'm going to take the calculator and plug in the first part to get my x value, plug in the second part to get my y value. So go ahead and do that. Plug them in and see what we get. Okay, -2, comma 3. My answer today is a coordinate point. That's what I'm looking for. However, if you do not want to memorize the formula, you need a straight edge out. We're going to talk about how to find it on a graph instead. Once you get your straight edge, go ahead and graph A and B. So -4, 4 is A, and 2, 1 is B. I don't even have the formula memorized because I know how to do it on a graph, and I think it's way faster. But again, if you want to remember the formula, go for it. If you'd rather do it on a graph, I'll give you graph paper. Okay, here's how this works. You still have to know that it needs to be 1/3. That doesn't change. We're going to have that every time, okay? I'm going to count. It's like counting slope. So to get from A to B, how many units am I going to have to go down? How many units am I going to have to go over? Okay. We don't want to reduce that. We're just going to leave them right here. This is my work. And if you decide to do it this way, this is enough to show your work. What is 1/3 of 3? 1. So let me go down 1 instead. I always need to start back at A because it says A to B. So you start at the beginning point A. Okay. What is 1/3 of 6? 2. Thank you. So you go down 1 over 2. Here's my new point. What is that point? The exact same point we got by doing the formula. So you still have to find K, but you just take the amount you went up or down, multiply it by K, the amount you went left or right, multiply it by K, and repeat the process. You'll find the point. Yes, Jacob. As long as it goes parallel, it's fine. You're right. Because it would be in the same proportion. So he said instead of finding the bottom one, if you go down 1, as long as you draw a parallel line, you're going to be at the right point anyway. So that's fine. Alright, I want you guys to try 5 and 6. That's it. Just do it one way. I don't care which. If you would like graph paper, I will pass some out. Before you get started, though, I want to make sure you understand how to find K. What is K for number 5? And number 6? Okay. Okay. If you want graph paper, I'm going to pass some out. But if you want it, actually, I'm going to pass out a graph card. You can divide it in half. If you want a graph card, I'm going to pass one out. Which one do you want to do with the graph? I don't guess it matters. 5. Okay, let's start with that then. Alright, so if I've got my graph, I do have to have a graph that's big enough to have -6, 5 in it. So I'm not going to make it completely in the middle just in case. So -1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Almost didn't make it big enough. There's A, 2, -1, 2, 3. This one's kind of a large segment there. But that makes sense since it's 5/8. Alright, what does it take to get from A to B? How many are you going to have to, units are you going to have to go down? 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay, what is 5/8 of 8? Yeah, it's 5. Which we could do what Jacob said, 1, 2, 3, 4, 5, and just draw a straight line and find it. We can make sure that that really works. How many units over is it? It's also 8, and 5/8 of 8 is 5. So 1, 2, 3, 4, 5 is exactly what he said. So we could just do that instead. So you go down 5, right 5. So where is that point subdivided? -1, 0. And I don't have to, this is the answer I'm looking for. Nothing else there. If you did them on graph paper, you need to glue your graph in there. Alright, now number 6. I said I would do one with the graph, one with a formula, so we're going to use the formula for number 6. We already have that k is 3/5. The formula is x1 plus k times x2 minus x1. Do a different color just to see the difference here. And y1 plus k times y2 minus y1. What did you guys find for the x value? -2. If you're having any problem, type that in the calculator or figuring this out. Let me know. I'll help you when you're working on your assignment. How about the y value? -2, -7. Make sure you're putting a comma and make sure you're putting parentheses around there. A lot of people don't put parentheses around them, and that's not mathematically correct. Alright, that is all for subdividing a segment. I'm going to tell you the assignment, and then you're going to get started on that. It is in your book. It is page 647. Five through 8. 13 through 16. If you want graph paper, it's in the back of the